Hi, my name is David Wilburn. Today, I'm going to show the derivation of the quadratic formula using completing the square. Now, for this video, and for you to follow along with what I'm doing, you're going to have a really good knowledge of factoring. You're going to have a solid knowledge of adding fractions and finding least common denominators when you have variables. You're going to have to understand the proper factoring of a perfect square trinomial. So we're going to start out here with what's known as the general form, standard form of the general quadratic equation. We have ax squared plus bx plus c equals 0. Okay, so in order to complete the square, the first requirement is that we have a coefficient of 1 for the x squared term. That's not the case here. We have a coefficient of a. So what we need to do is we need to divide every term by a. So when we divide every term by a, the first term, the a's cancel, and we're left with x squared plus, in the second term, we end up with b over ax. In the third term, we end up with c over a. And of course, 0 over anything is still just 0. Okay, so we've completed our first step. We have a coefficient of 1 for the x squared term. So now, our next step in completing the square is going to be to find this c term that will make this side of the equation a perfect square trinomial. But first, we have to get rid of the c term that currently exists. So since we have a c over a added to this side of the equation, we have to subtract it from both sides of the equation. Because as you know, whatever we do to one side of the equation, we have to do to the other side. So I'm going to rewrite again. X squared plus b over ax. I'm going to leave a space because I have to create a new c term. Equals negative c over a. Okay? Now, in following the rules for perfect square trinomials, what we're going to do is we're going to take the existing b term divided by 2 and square it, and that'll be our new c term. So what we're going to end up adding to both sides of the equation is b over 2a squared. So we're going to add it over here too. So I rewrite, and I'm left with x squared plus b over ax plus b over 2a squared. And that equals negative c over a plus b over 2a squared. Okay, the next thing that I'm going to do is I'm going to do two things simultaneously. I'm going to, now that I have a perfect square trinomial, I'm going to break this down into the factored form. The factored form for every perfect square trinomial is x plus or minus, depending on the sign here, plus or minus the square root of your third term. So what I end up with is x plus b over 2a quantity squared. That's the factored form of that perfect square trinomial. And on this side, all I'm going to do is I'm going to change the order of these two terms. So what we have is x plus b over 2a quantity squared equals b over 2a squared minus c over a. So I'm going to come up to over here and rewrite. That might be a little high. So now, the next thing I need to do is I need to simplify this side of the equation. I need to find a least common denominator here. But remember, this is a squared term. So I need to go ahead and deal with the fact that this is squared before doing that. So I'm going to rewrite this side again. Really, for a while, all I'm really going to be doing is bringing that side down. It stays pretty much the way it is until I get close to the end. So this gives me b squared over 4a squared minus c over a. Now I can find the least common denominator. And the least common denominator is 4a squared. What did I multiply a by to get 4a squared? I multiplied it by 4a. So I'm going to multiply both of these fractions by 4a. So what I'll get, like I said, this keeps coming down. But what I get is b squared over 4a squared minus 4ac. I multiplied c by 4a over 4a squared. And since these have the same denominator, now they can be written over a single fraction. This is coming down again, just the way it is. And this becomes b squared minus 4ac over 4a squared. Now I'm at the point where I'm finally ready to do something with this. What I'm ready to do is I'm ready to take the square root of both sides of this equation. Take the square root of the left side and the square root of the right side. When I take the square root of this side, basically the exponent of 2 just goes away. So I'm left with x plus b over 2a equals plus or minus. Now, here's where I notice I have a perfect square in the denominator, so I can bring that, take the square root of that, but I can't do it with the numerator. The denominator, the square root of 4a squared, is 2a. At this point, there's only really one more thing to do in order to solve for x in this equation, and that's to subtract b over 2a on both sides. Oops. Bad habit, erasing with my finger. Minus b over 2a minus b over 2a. And so what I'm left with is x equals negative b over 2a plus or minus the square root of b squared minus 4ac also over 2a. This is wonderful. I have two fractions that have the same denominator. That means they can be written over the same fraction. And I'm going to rewrite that again up here. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And that, my friends, is the quadratic formula. Thanks. Have a great day.